presentations, and they also like to answer the questions with very out of this world answers. Like a lot of it makes no sense, but a lot of them tend to focus on the experiments, especially if we bring candy to the classroom. They love candy. But I've learned that they like the experiments that we've done. So I've noticed that keeping it simple is the best way to go.
How's that hard to kiss acoustics? I know some background noise. Can you hear Lenin?
Okay. So keeping it simple, I feel is the best way to go. We teach third graders, so I don't know what other grades you guys teach. But keeping it simple is the best way to go. Keeping it straight to the point and teaching them everything that needs to be taught, but broken down in a way that they could pretty much understand. So science is very, very big on using very big words, pretty much. So if we could break it down, make it simple, the students tend to pay attention more. We usually like to take a whiteboard. They usually supply us with a whiteboard where we could draw. If we could visualize whatever we want to show them, it's a little bit better than just verbally telling them, because a lot of the kids, they have an imagination where they think of a lot of things. So if they visualize it and they see it, they could grasp it better. You know, that's it. Like I said, the kids tend to get excited when you bring things that they gravitate to, like candy. Even though they can't eat the candy, it's always good to like at least work with something that they like. Like we did rockets. They like things that blow up, you know, things like that. It's pretty good to keep in the focus of experiments, to teach the students pretty much force or gravity or whatnot, any scientific jargon. Let's see. There's times that experiments don't tend to work pretty much how you want it to work. I know last year we did the goo experiment, but we used borax, water, glue to make the slime, and that's a mess. So we've learned to like tweak the experiments and go simpler by just using cornstarch and water with food coloring, which still hit the same markers that we wanted to hit to the students, but in a simpler way, without us going all crazy, mixing everything, and having the students, giving them more time to actually grasp whatever we're trying to teach them. Because sometimes if you're not really prepared for the experiments, you will have to waste their time trying to like adjust to anything that didn't go right during the session. So it's best to optimize the experiment and see what works best. If there's another way to hit that point, which is simpler, it's the best way to go. I mean, they are third graders, so we can't expect them to understand everything fully, but I feel like at the end of the day, if they do understand where we're coming from, opposites attract, right? I think so. And all that jargon, hey, that makes me happy, that makes them happy. They'll go home to their parents. Hey mom, did you know that opposites attract and this and that and the third? Yeah, oh, you know, and that makes them happy, especially when they could take a part of the experiment that we did home and they enjoyed it. Like when we did the goo, they got to take the goo home in a little baggie. They were so happy. So it's always good to see smiles on their faces. Let's see. Now, I feel like the best way to encourage the students in taking the path of STEM is to letting them know that a lot of the things that they deal with, behind it all is either science, engineering, math, or some other technological thing. Like video games, You have your Xbox. Tell them, listen, the Xbox, you play it, but inside of it, there's a lot of engineering that goes within it. You have your chips, you have all this and that. The video games, you have a lot of computer programmers. They write the program for all that. They tend to see it and they're like, that's pretty neat. I would like to do that, you know? Because if they enjoy that, they probably will enjoy the behind the scenes of whatever they're dealing with, you know? Let's see. I think that was all the points I wanted to make, because I haven't been I've been in the program for at least a year and a half now, but the main person that actually gets us all together is Juan Valentin, which just got here. So I'm sort of like the behind the scene guy, not the front tier person. But that's pretty much the things that I've seen as a volunteer throughout my whole volunteering sessions. And it's been nice, you know, and I feel like there's a lot of things that could be made better. But so far, so good.
Thank you, Lenin. Let's hold our Q&A until everyone made their presentation. So, Danielle.
So again, I'm Danielle, one of the co-chairs for the Kids for Best of ReSET at the Patent Office. I'm kind of going to be reiterating a lot of things that Lenin was saying because our groups are similar. Currently, there's about 8 to 12 volunteers that go out to Whittier Elementary in Northwest DC. It is a STEM school. We work with 3rd graders in the fall and 4th graders in the spring, and conduct our experiments during the day for about an hour. With almost 4 years under our belt, we have definitely learned things that have worked and things that haven't worked so well. Overall, I think the best approach in effectively teaching the students has been to emphasize that incorporating hands-on experiments and applying them or having them be related to real-world applications is really key. Bridging the gap between the student feeling like, it's just little me sitting here at my desk, and seeing a scientist on TV with a lab coat, or seeing someone win the Nobel Peace Prize for any type of invention, letting them know that they can indeed be the inventor, they can indeed be the scientist, the engineer, the mathematician, and that science, like Lenin said, is around them all the time. In this way, we try to present our experiments with hands-on materials, things that they can readily go to the store and get and reproduce. So, for example, one experiment that we have found success with is called Candy Bridges. Candy Bridges, we buy a whole bunch of gumdrops, Starbursts, caramels, and toothpaste. And they're able to build a bridge, learn about shapes, angles, which shapes support weight better, squares, triangles, and build their own bridges working in teams. And so that also teaches them to work in groups, brainstorm. It's definitely hands-on, and they say, well, I need help. And so they may be a little apprehensive at first, but you help them a little bit along, and they learn. And then we test their bridges, or they test their bridges with putting books that we have in their classroom on top. For instance, to put 2 desks together, the bridges are on each ends of the desk. Books on top, and they're screaming like 1, 2, 3, as many books are placed on top. And so they just get really excited about seeing that they can do it. It's them doing the experiment, not us even trying to put things together, seeing what works and what doesn't work. So, another example is a dry ice cream experiment that we do with them. And they learn about carbon dioxide, sublimation, the states of matter. And of course, they get to eat ice cream at the end with sprinkles. But it just reinforces that science, engineering, and math is attainable, it's relatable, because it's around them all the time. And also they can go out, go to the store, go back home. They ask if dry ice can remember. Where do you get dry ice from? Because they want to do it. They want to do it at home. So working in conjunction with the teachers before the semesters even start, we try to relate our experiments with their curriculum. So maybe they've already learned about gravity, have already gone into multiplication, things like that. We try to figure out what concepts they're learning now, what concepts they're about to learn, so that we can incorporate those skills into our experiments. So that we can, for instance, stop in the middle of an experiment and say, all right, let's take some measurements, let's do some calculations, and help them to apply, again, the experiments with things that they're currently learning in their classroom. As John mentioned, we did the robots experiment where they have to, well, we created a course, mapped out a course on the ground with tape. The robot has to hit certain points from a start to an end. And the students are able to program, it's a really simple robot where they literally measure the distance, tell the robot if it's going left or right, for what angle to turn. So they're working in groups, they're programming, they're taking measurements, they're able to problem solve, and they're often encouraged, even after that experiment, to create an even greater challenge for themselves by creating their own obstacle course after that, saying, we want to make it harder because we want to try something else. But I think the most important thing is to be flexible. In the classroom, everything's not going to go as planned. This year we tried to do something new by incorporating a poster that has the scientific method mapped out. So it's a chart that says question, hypothesis, testing, data, results. We had 2 classrooms, because we have so many volunteers, and also 2 classrooms in the 3rd grade. One classroom said that they were able to use the chart effectively throughout the experiment to keep the kids on track. But then another classroom said that there wasn't enough time to stop the experiment, review each step. So of course there's things that work and some things that don't work. We try to adjust. We only have 1 hour, so a lot of times that is difficult to cram in as much as we want to. But we try to continue each month that we go with similar concepts to reinforce, for instance, the scientific method. It's been fun, and a lot of the volunteers that I work with are here, and I'm sure they would agree that it's definitely a rewarding experience.
I can be much louder if I stand up. Are you okay? All right.
Project.